At Sturgeon Heights, 7 out of 8 classes recycle paper. If there are 64 classes in total, how many do not recycle?
56.
Close. You would answer that right if the question said how many do recycle. So what do we got for our ratio? We know that 1 out of 8 don't recycle, 7 out of 8 do. So if the question was how many do, 56 would be the right answer. But then if 56 is the right answer for how many do, how many don't? 64 minus 56, or look at this ratio, and if you think here, how do I go from 8 to 64? I'm getting bigger, so I'm going to be multiplied by something.
8.
Multiplied by 8. So what is our x going to be? We multiply by 8. Our x is going to be 8. And so we can say that 8 classes do not recycle. So anytime you have a ratio or a fraction equal to a fraction, this pattern happens. When you're going from smaller to bigger, you're multiplying by something. If you had to go from bigger to smaller, you would be dividing by something. And we're figuring out what that ratio is. So you can sometimes just look at it that way. There are other techniques as well. There's like a technique that we're going to use in our next unit when we solve for x is saying, if you wanted to get the x by itself, right now it's divided by 64. What's the opposite of dividing by 64? Timesing by 64. And so if I take this side and multiply by 64, you're going to learn in your next unit that what you do to one side, you have to do to the other side to make them equal. Okay? This, 64 divided by 64, will simplify to be 1 and go away. And on this side, you'd have to multiply fractions. 64 is technically 64 over 1. Do you see that you would get, I'm going to do it in 2 steps here. 64 times 1 would be 64, 1 times 8 would be 8. And you're left with 64 divided by 8, which is 8. So 2 ways of doing this here. I'm going to put this in a box. This is one way. That's going to be what we're going to use a lot in our next unit. Our next unit is going to be solving equations and trying to get the x by itself, a really powerful unit, a really important unit that you use lots, whether you're going to pre-calculus or into essentials next year. But the other thing is knowing ratios. And knowing ratios, if 2 ratios are the same.
That's really loud.
Yeah, that's the class. I don't know. So we could just say, hey, this is times by 8, so this has to be times by 8, and then the x would have to be an 8 that way too. So 2 different ways of looking at the same thing. It's nice to have different methods because sometimes one method, I like at the beginning here, I like the top method because it just looks super easy. But sometimes the top method might be harder than the bottom method might be.
Well, and just to add to that really quickly,
Yeah.
of course, when you found 56, so long as you understood the question, what it was asking, it was totally okay for, like, some of you may not see right away, 7 out of 8 classes that recycle, that means 1 out of 8 doesn't. This is a great question to help show that, but if you went with 7 out of 8 and got 56, that's okay too, because that approach could be just 64 minus that 56, right?
Mm-hmm.
Still getting you to where you want.
But
Lots
it's
of options.
important to take your time reading a question, understanding all the words. What are they asking? Jack's class, 18 of the students are tall and 10 are short. They must have a line,
I'm on the tall side.
right? They must have a line in that class. In Michael's class, 54 students are tall and 30 are short. Which class has the higher ratio of tall students to short students? Are there more tall people in Jack's class? Or are there more tall people? Well, there's obviously more tall people in Michael's class. He must be in a phys ed class because there's 84 people in his class. That's probably not a math class. Okay, but is the ratio bigger? Are there more per capita kind of idea? Are there a higher ratio of tall people in Jack's class or a higher ratio of tall people in Michael's class? If you look at it right now, do you get a sense? It's kind of, it's
We
kind
should
of,
do a- We
yeah,
should do a hands for who thinks
yeah.
the higher ratio is Jack's or Michael's.
Do we understand what they mean when they say the higher ratio?
Yeah.
Okay, like if there was another class with 9 tall people, only 1 short, that would definitely be the highest ratio. There's way more tall than short. This one is just under double.
Under a third.
This one's just under double. That other one's just under double. So let's look at the ratios. Jack's ratio, 18 tall over 10 short is 9/5. Michael's ratio, 54 over 30 is also 9/5. They actually have the same ratio. Tall to short
Oh, I made one simple error in my head.
in your head.
Well, cause I was going from 10 to 18 and not 10 to 28.
Ah.
Cause I was like, 30 would be. Oh no, I did it on the other one. 54 and 30.
Yeah.
Some other things you could think about for this one, okay? Right? You could do a percentage. If I wanted to figure out what percentage of people are tall in Jack's class, there are 18 tall people out of, what's the total? 28. And if we do 18 out of 28 as a percentage, right? How do we do that as a percentage? Well, we divide that to change it to a decimal. So 18 divided by 28 as a decimal is 0.6428, which is equal to 64 it's actually 29 after I round. 64.29%. Michael's class, as a percentage, there are 54, and the total amount of people in Michael's class are 84. And that is also 64.29%. So you could consider it as a percentage. You could consider it as the ratio, tall to short, tall to short. And when we reduce that fraction to lowest terms, it gives us a way of comparing it. We could also put this into our calculator and get a decimal, because sometimes the fractions, you reduce them and they're different and you still aren't quite sure, so a decimal might be a way of looking at it.
Alright, SCCU's direction, could we now have all the grade 11s and their teachers down to the gym, please, for our grade level meeting, all grade 11s, thank you.
Test, would it matter if you do like percentage over ratio?
No, in this one, which is the higher ratio, you'd get the same answer both ways. It did ask which has a higher ratio, so it makes sense to look at the ratios because that's what the question had mentioned, but both would be right.
Yeah.
Yes.
Una pregunta. Y en Jack, el 18 más 10 se divide por 2.
El 18 sobre
No,
20.
el del azul.
Aquí.
Se divide por 2.
18 dividido por 10 y estos dos, sí. Dividido por 2, ¿esto? Ya.
Ah, ok.
Y aquí dividido por 6, dividido por 6.
Ok.
But you know that in your calculator, when you get good at your calculator has it built in, it should if you have a good one, that you type this in and it will reduce it to lowest terms for you. So make sure you know how to use your calculator to do that. George can take a 40-minute flight to get to Minneapolis, or he can take an 8-hour bus ride to get there. Write a ratio that compares the time on the bus to the time on the plane. Give your answer in simplest form. So our ratios get us to deal with fractions. One of the things you're gonna look at in this question is, why should I not do this? What's a problem with just doing 40 and 8 as my ratio? One was 40, one was 8. Obviously, the plane takes 5 times longer than the bus, because 40 is 5 times bigger than 8.
Is it because it's not in like the most simple form?
Well, sort of, but there's another issue here. Like if I do 40 and 8, this reduces to 5 and 1, because they both divide by 8. And this would say, and this was my bus, no, this was my flight, and this was my bus. So if I do this, I would say, my flight takes 5 times longer than my bus.
Is it because it's minutes and hours?
Because it's minutes and hours, right? If you take out the units, this is saying that the flight takes 5 times longer than the bus ride. Then he's like, oh, he should take the bus ride.
Yeah.
He's gonna get there so much faster. No, we have to deal with the same unit. So either we have to change the hours to minutes or change the minutes to hours. There are 60 minutes in an hour. So 8 hours is 8 times 60. It's 480 minutes. So this, I'm gonna put an X through it. It doesn't work because your units weren't the same. Once we get the units the same though, 480 to 40. Can you divide both of those by something? Can we get that into lowest terms? If you want, you can type this as a fraction into your calculator. And you'll get 12, which is 12 over 1. So as a lowest ratio, right? You can always change a ratio to a fraction to reduce it to lowest terms.
So here, does
Yes.
it matter if, like if 480 is like, in the ratio, how is it like?
It doesn't matter if you wrote the, right, as like in here,
40 to 480.
Yeah,
it says in this question, because the question she's asking, what happens if I wrote it this way? Well, that's really yellow because I was gonna underline something. How's your eyesight today? Right, this is bright and sunny. Do you know what we're gonna get tonight?
No.
Snow! You know what snow rhymes with? No!
4 to 5 inches of snow.
No!
Sure, what's going on with those taking care of?
But I saw double digit positive temperatures on the weekend.
Don't do it.
That's exciting.
Holy.
Okay,
it looks like a lot.
so
What?
the question is, do we write 480 to 40 or 40 to 480? Technically, both are same ratios, but this,
Like, it looks,
I'm gonna underline this. It said write a ratio that compares time on bus. So I'm gonna put B above that number. Compare it to time on flight. I'm gonna put F above that number. Because the question said, do bus compared to flight, it makes sense to do the bus first, the flight second.
Which is tough in this question because the first thing you read is the
Yes. It's kind of, so if you did it this way, do you think Mr. JR would be mean and take away all your marks, or?
Yes.
Yeah, probably, right? That's what you're used to. Sorry about that, guys. All the trauma. There is, once you graduate from high school, there's a help group out there. Anyone who's been in my classes,
Yeah.
Yeah.
See.
Mr. Shirk runs it. He makes money. It's our side gig.
Oh, whatever gets us closer to retirement.
When a bike is in fourth gear, it does 3 turns of pedaling, so the rear wheel makes 7 turns. If the pedal turns 12 times, how many times will the rear wheel have made? So first of all, sometimes in these questions, you're gonna read them once and go, huh?
Yeah.
And then you have to read it again and try to make sense of it. So what's happening here? On your pedal, okay, this is how gears work, right? On your pedal, you go 3 times around, and in those 3 times around, your back tire turns 7 times. That's really gonna get you to go far forward, right? So if our ratio was 3 to 7, and it has to equal a ratio of 12 to something, and sometimes in your ratios, I think it's not bad if, okay, pedal, wheel. If you're gonna make a ratio equal to another ratio, you have to make sure that order is the same. So my pedals to the wheel, okay? Can you see what you multiplied to go from here to here? Times by 4. So if you do the same thing here, times by 4, you are going to get 28 turns. You could also write your ratios as fractions. So 3 to 7, 3 sevens equals 12 to x, 12 over x, and we see that same times by 4. So here I have to times by 4 as well. This is one, if you try to get x by itself, would not be a recommended method.
Unless you.
Flip the fraction. I mean, there's extra work that needs to be done, right?
Or you know you're cross multiplying,
Right.
which makes it quite easy.
Quite easy, but you still have, like, look the math you'd have to do. 7 times 12, you got 84, and then you have to know how to divide 84 by 3. That's still a little bit tricky math. So this, I think, is a better method in this situation.
Yeah.
So you're gonna buy a car, and you look and you like the luxury car. And the same size of car, the mid-size family car, the cost ratio is 3 to 2. And then the mid-size car, which you look then at the economy one, is 2 to 1. So what is the ratio between the cost of a luxury car and the cost of an economy? There's 2 ratios there, and we have to find the third one. So this ratio means 3 to 2, that if you were buying the luxury car, it's going to cost you $3 signs. And maybe that luxury car. Yes, you're here.
That's crazy.
So maybe we're thinking that each of these dollar signs is $10,000. So you could buy a used, maybe this is a used luxury car for $30,000. The ratio of 3 to 2 tells us that if the luxury car costs you $30,000, the ratio of 3 to 2, how much is the mid-size family car going to cost you? $2 signs. Each dollar sign we said was $10,000. that would cost you $20,000. And then the economy car, its ratio is 2 to 1. So that economy, same size, but in the economy, would only cost you $10,000. So I used the dollar signs to show the ratio of 3 to 2 to 1, but then our dollar signs could be different amounts depending on how new the car was. Like if it was brand new, maybe those dollar signs would be $30,000 each. Right? You can buy the super nice luxury car for $90,000 new, the decent family car for $60,000 new, or you could go to the economy for $30,000 new.
And that would be on par.
Right.
That would be reality.
I think those numbers
Brand
are actually are brand new. I think those numbers are pretty accurate actually.
As long as you don't get into the truck business.
So then what's the ratio between the blue and the black? Because this question is saying what's the ratio between the cost of the luxury car and the cost of the economy? Well, we did it here, 3, 2, 1. So our ratio between the blue and the black would be 3 to 1.
Mr. Chair, you said something about costs reminded me of that my like elderly neighbors died and they one day just started struggling to.
Oh my gosh. That's pretty dark.
Can I leave it to Chloe to brighten up our day? This reminds me of when somebody died.
Yeah, exactly.
I didn't know the guy. I never had a conversation with him. He used to just smoke on his porch all the time.
There you go.
Well, that might do it.
Don't smoke.
Yeah.
Alright.
Why would he?
Bro.
So here's a box for you guys to fill in your notes. Rate, like a ratio, is a comparison between two numbers or measurement. But the two numbers in a rate have different units. Oh ho!
Late, but you're here. Good morning.
Sorry for that pause.
You're bad.
Wait, we're all
So a rate, here's a rate, you're
You could figure
30 pages in 15 minutes, you're comparing two things that have different units. 100 push-ups in 5 minutes. Unit rate. A unit rate is a specialized ratio that compares two different units where the second one is always 1. Or a certain unit. They do this in grocery stores. Oh, there's the number one question. When am I ever going to use this in real life? Like if I go to a grocery store, this you use in grocery stores. They have the unit rate for certain things. You go buy coffee, and it has a whole bunch of different sizes, a whole bunch of different prices. But if you look on the price thing, there's a unit that says this is the cost per 100 grams.
Yeah, first, yeah.
And the 100 grams is the unit rate. It's always 1. In this case, it's 1 in centigrams or something like that. But, right? A car is traveling at 100 kilometers per hour. The second unit, 100 kilometers per 1 hour. The second unit is 1. For the cost of... I don't really understand that second exactly. Cost of something is $22 an hour. I'm thinking 22. Maybe this is supposed to be, this makes more sense to me if I take out an R. Cost of a steak is $22 a kilogram. It's actually probably more expensive now.
No, we don't buy steak.
No, because it's too expensive.
Yeah.
Right.
Like if just, we wanted just one steak, which is 4 steaks
Right.
per every 2 weeks. It would be I mean, sometimes we're like 350, 400 bucks on groceries. And we have like 5 bags.
I tried different variations, but my kids don't like the wooden stakes. 160 bagels in 4 hours. If you wanted the unit rate, you'd have to figure out how many they make in 1 hour. So this is what we're trying to figure out. If we reduce this, it becomes 40 bagels per hour.
They don't like the wooden stakes. They're vampires.
Vampires. My kids are vampires.
I mean, would you rather have a loud, like loud neighbors or
Yeah,
quiet
good point, good point.
Loud
What do you
neighbors.
Why?
I would, because then I can be loud.
True.
But you're always loud.
If a bus travels 2,531 kilometers in 26 hours, if we find out how many kilometers per hour it's going, that would be its average speed. So we take 2,531 divided by 26, we get 97.3 kilometers per hour. Now you know how to figure out your average speed. Think about how far you went, how long did it take you? You can divide that and you get your average speed. Okay? And if your average speed is over the speed limit, that is not good. That means you were really speeding the whole time. Sally can pedal her bicycle 20 kilometers in 2 hours, while Antonio can pedal his bicycle 18 kilometers in an hour and a half. Who's faster? Who is going, they enter a 24-kilometer race and they can pedal at those same races? Who will win the race? And by how much time?
20 kilometers, 2 hours.
So does it make sense that Sally is going 10 kilometers an hour? It will take her 2.4 hours. What do we got? Speed is distance over time. You can switch the time and the speed here, and you get time is distance over speed. So for Sally, right? 20 kilometers in 2 hours means that she is traveling 10 kilometers per hour.
Sergio.
Yep.
Is it possible to bicycle over the speed limit?
Possible, but you probably don't want to. I think though on certain downhill mountainous routes, there have been cyclists that have gone over the speed limit.
Oh, for sure.
And that would be probably exciting and scary.
Like in Greenland. There's a road in Greenland that
If we take her 24 kilometers and divide by her speed of 10 kilometers per hour, we find out that this takes her 2.4 hours. Antonio's speed,
maybe just so that.
18 kilometers in 1.5, that's 12 kilometers per hour. You could already tell that Antonio's going to win, because he's traveling faster. So once you find the unit rate, you can say, I know that Antonio's going to win. If he goes 12 kilometers an hour, how long is it going to take him to do the 24-kilometer race?
Not even.
Exactly 2 hours.
Oh, you said to do 24, not 20.
Yeah. So Antonio's going to win. 0.4 hours faster. Since there's 60 minutes an hour, 0.4 times 60 is 24 minutes. Poor Sally.
Well,
She
let's
should've-
Speed up.
Yeah.
Yeah.
Just
Y-
sabotage her.
Y una pregunta, ¿y por qué Antonio le gana a Siri?
¿Por qué Antonio gana?
Sí.
Porque es más rápido. Mira, Sally, 10 kilómetros por hora.
Sí.
Antonio, 12 kilómetros por hora.
Pero solo es un 2 de diferencia.
Pero es más rápido.
Max.
Or like a brain.
Dunsky's.
And then I come crashing into a mailbox.
Who is running faster? Justify your answer. Is it Evan who runs 23 meters in 5 seconds? Is it Derek who runs 100 meters in 14 seconds? Or is it Ward who runs 1800 meters in 8 minutes and 45 seconds?
These
Notice
are,
the Evan doesn't have very good stamina.
guys, just so you know, these are 3 people you know. I'm looking forward to seeing who's fastest.
I know these 3 people.
Do you know an Evan?
Yeah.
No?
Just thought so.
I'll look right there.
So Evan runs 4.6 meters per second. Pretty impressive.
Do you guys know Mr. Thorsteinson? Right beside us? His name is Derek. Looks like Derek made this question.
Looks like Evan can beat Derek in a foot race, even though Eric.
Oh, right. No, you're the faster. Oh,
No, I'm not faster. I'm a smaller number. I don't go as far. He goes farther than me. He's going faster. Man,
I think he may have made this question.
what about Ward? Oh, we have to do units. I'm already tired.
Ooh.
8 minutes and 45 seconds. That is 525 seconds of running, which is way more than apparently Evan could ever run. But 3.43 meters per second, he is the slowest. Derek is running the fastest. Is this a fair comparison? How fast someone can run in 5 seconds and then comparing them to the person who ran for 8 minutes and 45 seconds straight?
Absolutely not.
No.
Although yours was in 5 seconds. So you should have been the fastest.
We won't talk about that.
Now,
It
now with those 3 people,
It was
would that be the
uphill
real
against wind.
thing? No. Although I don't know how fast Ward would be, I'm pretty sure Evan would be the fastest.
I don't know.
You think Ward could be you?
What?